Exercise 5I, let's have a look. We're now still doing completing the square, so you still need to know how to complete the square. Maybe the benefit of this exercise is you don't necessarily have to factorize, meaning you don't have to do difference of perfect squares. Okay, you can actually just solve by inverse operations from there. I prefer that method, but again, it's up to you which method you want to approach, okay? Before we start, let's do a reminder. Completing the square, here's your expansion formula, which is pretty much heavily reliant on the concept or understanding. So say I gave you something like this equation, x squared plus 10x, and then there's that plus 25. Now ignore the plus 25. It was just x squared plus 10x. What must go inside the brackets? Can I please have, let's go with Rowan. Do you remember how to figure out what goes inside the brackets, just knowing x squared and plus 10x?
Well, I know it's x plus 5 because 5 squared is 25 and x squared is 6. X squared.
X. Good. The key part was, imagine if I didn't have 25, or if it wasn't 25, say if it was like 30. The key isn't the last number, the key is the middle number. Half the middle number will give you this term, and then like you said, Brian, you said x squared is x squared. So that's always true, and that's one of the key things about limitations of completing the square, because literally, like Brian said, x squared is x squared. You can't have any coefficients in front of x squared. So if you have 2 or 3, then this thing breaks. That's why we always need to make sure that the coefficient of x squared is currently 1. Okay, so then that's why, like he said, when you square the first term using this formula, square the first term, you should get just x squared. If it was a 2, it becomes 4x squared, and that's a problem. Okay, because that means then AB has a factor of whatever other factors that we don't know. Okay, so always the limitation to completing the square is that the coefficient has to be 1. And then how do you know what's inside this bracket? The value, it's not the last number, it's the b term, half the b term to get the middle one. Okay? Now, let's practice our completing the square again. So we're always looking for the b term. Halving that will give you this number, and we know this should be x, providing the coefficient is 1, right? Let's solve this problem. So, likely if you try to use cross method for this example, it is not going to work. Okay, so these examples in exercise 5I, even if you try to do cross method or grouping method, you're not going to be able to solve it. The reason why is because the x-intercept doesn't always have to be a whole number. It can be a fractional number. And when it's fractional, that's why this breaks. Because when we do the factors, we rely on the fact that it is a whole number. So I'd say factors of 2, you say 1 and 2. Then we look at coefficient of x, which is 1, so we say factors 1 and 1. But really, we're assuming that the answer is going to be a whole number. We don't know that. The x-intercept could have been a decimal, it could have been a fraction. That's why when this doesn't work, doesn't mean you've done something wrong. It just means that potentially the x-intercept, if there is one, it may not be a whole number. Okay, so when you can't do cross method or grouping method, the next method is completing the square. Okay, so here, even if you tried it, you can see that no matter how you pair 1 and 1 and 1 and 2, there's no way you're going to get a 6. Okay, 1 times 1 is 1 and 1 times 2 is 2. 1 and a 2 can never get you a 6. So therefore, cross method won't work. So here, this is where we then apply using completing the square. So using that same concept again, we've got x squared, we've got minus 6x, and we've got a plus 2. It's not the last number that matters, it's the middle one. So this one's a minus 6. So if I were to write this as a perfect square, what number, now what should go into the brackets? Yes, Molly? -3. So it should be x minus 3. So like Ryan said before, x is always going to be the x squared. Coefficient is 1, so it makes sense. The -3 is through the half of -6 gives you the -3. And then that tells us now what the last number should have been. We've got a plus 2, but we don't want a plus 2 because for it to be a perfect square, the last number must be what, Nishi? What should the number be here? Oh yeah, the overall is -7, but I want to know what should the number be here so that you get a perfect square. Meaning if I expanded this bracket, I'd get that. +9, very good. So this is the number I want. plus 9. Because that literally would be this factorized. Okay, because we're using that expansion formula just through logic. We know this should equal. But the problem is the plus 9 is made up. I know I want it, but I don't have it. That's why mathematically we say, well, the equation is x squared minus 6x plus 2. We put in a plus 9 because we know it makes it look nicer. And then we have to then subtract 9 because it never existed. So plussing 9 and then subtract 9, technically I've never done anything to it. But visually I have. Visually I have changed this into just 1x rather than having 2x's to solve. 1x is much easier to solve. And then minus 9 plus 2, this is where Nishi was saying that's minus 7. That is correct. Minus 7, don't forget it's all equal to 0 at the moment. And this problem, up until this step, is called completing the square. Okay, so moving from general equation to turning point form, this is complete the square. So when they say solving by completing square, up to this step, you can do difference of perfect squares. So something squared minus, you can make a 7 something squared. You can do difference of perfect squares. I personally like, I'm going to show you both methods as well. So method 1, I personally like just doing inverse operations. Okay. So let's split up the two techniques. So you've got x minus 3 squared minus 7 is equal to 0. And the same thing over here, x minus 3 squared minus 7 is equal to 0. The textbook will likely want you to train difference of perfect squares, and it's fine. If you're not good at difference of perfect squares, it's an opportunity to practice. So from here, you can say this is already something squared, minus now square of what will make 7? Yes, Amy? Root 7. So this now becomes a squared minus b squared. So you can use difference of perfect squares at this point. You can say a must be x minus 3 and b must be root 7. So according to the formula, it should be a minus b and then a plus b, right? So the answer for this bit, anyway, when you factorize it, it should be a, which is x minus 3, minus b, which is root 7, and then a again, plus root 7. So I'm just simply using the rule a squared minus b squared is equal to a minus b bracket a plus b. That's what DOPS is, difference of perfect squares. Yeah? So if you've got something squared minus something squared, whatever you're squaring in the first bracket is a, the second one is b. So the first one was x minus 3, the second was root 7. Okay, so this is what the textbook would like you to practice, and that's because it trains you to practice DOPS a bit more. I personally think it takes a bit longer to get to the answer because from here, you then use null factor law that you learned from 5G. So null factor law says one of these, if they're timesing each other and it equals 0, one of them must be 0. So you would say x minus 3 minus root 7 could equal to 0. If that's true, well then add 3 on both sides and plus root 7 on both sides and you get 3 plus root 7 as one answer, or you could have got the other way. You could have got x minus 3 plus root 7 is meant to equal to 0. In this case, x would then equal to 3 minus root 7. Okay, so you got two scenarios there. Two x-intercepts, because that's what you're solving for. That's the textbook way. I prefer, and you can be flexible here, I prefer just literally doing inverse operations. So method 2, this is what I would have done. Method 2, I would have just simply said, let's get rid of everything. The benefit of having just one x is you can do inverse operations like you have since year 7. Get rid of minus 7 by adding 7 on both sides. So add 7 on both sides. Whoops. Add 7 on both sides. That cancels out. You will get now x minus 3 squared is equal to 7. To get rid of a square, what do?
Root it.
Square root. But when you square root, this is the only part you have to be careful of. What do you have to make sure? You do it to both sides. Plus minus. When you square root a number, there is both a positive answer and a negative answer. And if you've forgotten why, it's because when we say square of what gives you 7, it could be square of a negative root 7 still gives you 7, or square of a positive root 7 still gives you 7. If that was confusing, another way of saying it is Imagine that that number was 9. Square of what number gives you 9? Well, it could have been 3, or it could have been -3, because -3 times -3 is still positive 9, and 3 times 3 is also positive 9. So every time you square a root, there is 2 possible answers. There's a plus and a minus answer. So your next line, if you don't put that in, you'll only get one of the answers, but you're meant to have plus or minus root 7. Okay, so square rooting both sides, make sure to put in that plus or minus. Then finally, to move that 3 across, you just add 3 on both sides. -3 cancels out with +3, so you get x is equal to +3 plus or minus root 7, which is exactly the same answer as this one. So you have 2 scenarios. It could be 3 plus root 7, which is this one, or you could have 3 minus root 7, which is that one. Okay? So out of the 2 methods, I prefer inverse operations. I just think it's quicker. But method 1 practices more theoretical knowledge. So if your theoretical knowledge is not strong, if you don't know how to factorize often or quickly or identify them, this is good practice. Okay, that's typical year 11 stuff. The other side is me being flexible with the mathematics to solve. Okay, so I just think of what's the most efficient, what's the quickest way to get there. Sometimes doing it this way, method 1 is nice for simplifying and solving sort of problem-solving applications. And then sometimes if I just want to get an answer, then method 2 is better. So just being more flexible. But as you're training, then method 1 is good for training. Method 2 is just simply getting your answer to sketch and all that. Okay? So today's lesson, can you see how we're combining? That's your previous lesson, 5F. This bit is pretty much 5B or 5C, factorizing. Then you get to this bit, 5G, null factor law, and you get your answers. That's how they all sort of link together. Okay, so that's why each exercise you need to know. How do you know when to use completing the square? When cross method doesn't work. So 5D and 5E is a problem. That's when you use 5F and then 5G. Yeah? And then 5I. Cool? Let's do one more example just so that you get a feel of it. So I'm going to stick to method 2 just because I think it's more efficient. Here we go. Same thing again. We've got x squared plus 4x and that minus 14. You can try using cross method, but it's not going to work. And we know it's going to be a completing the square problem. So here we go. Same thing again. I've currently got x squared and then a plus 4x. I want to use completing the square, so it means I need to figure out the expression. What number should go inside the brackets? Because then that allows me to know what the last number should have been. So what goes inside the brackets? Let's go with Joanne. What do you think goes inside the brackets? Positive 2. So it's positive x plus 2. So again, like Rowan said, square of x will always give you the x squared, and that plus 2 doubling plus 2 gives you the plus 4x. And then what's the last number? What should the last number be? Let's go with Mira. So that last missing number there. 4. That's very good. So it's the square of whatever the constant is. So once you know the number in here, squaring the last number gives you the number you need. Now square of 2 gives me 4. But I don't have a 4. I have a minus 14. So I'm going to put a plus 4 because I want that positive 4. But if I put a plus 4, I have to subtract the 4 because it never existed. Then we work out the outside. Minus 4 minus 14 gives me negative 18. And then from this step, it's up to you whether you want to do method 1 or method 2. I prefer method 2. I like inverse operations, just quicker. So I would have just said add 18 on both sides. That cancels out. You're left with x plus 2 squared is equal to positive 18. Getting rid of the square, you square root both sides. But when you square root, what do you have to be careful of again? Plus minus. You must have the plus or minus root 18. Don't leave it as root 18 where you can simplify. You must. Go back to your cert skills. How do you simplify root 18? What does that come to, Nishi? 3 root 2 because 18 is 9 times 2 and 9 can be square rooted to 3. So hence, this can be simplified to as x plus 2 is equal to plus or minus 3 root 2. Because if you square root the 9, you get the 3. Or you can think of it as root of 9 times root of 2 is root of 18. Okay, so that's more simplified. Then finally, subtract 2 on both sides. So my answer is x can equal to negative 2 plus or minus 3 root 2. Have you noticed the x-intercepts are not whole numbers? All of these contain a surd, which is an irrational number. It's likely it's going to end up being a decimal version. That's why completing the square will be able to solve for irrational solutions. Cross method relies on the fact that they're integers, meaning they're whole numbers. Okay, so not every solution is going to be a whole number. Ideally, we want them whole numbers, but you will get problems where you'll get decimals and fractions. Okay? How do we feel so far? Pretty good? That's revision of last session, completing the square. How many more problems do I have? I'll leave that third one for you, but I'm going to jump to the next page. Jump over to the next page. I'm going to pick the one where you have a 2 at the front. So this problem as your last example for today. 2x squared plus 4x minus 1 equals 0. So again, if you tried using cross method, it's not going to work. So at this point, you can use completing the square, or at least up to this point, most of you only know completing the square. I haven't taught you quadratic formula yet. So completing the square, you can only do that when the number in front of x squared is 1. The problem is that 2. Then we can't say inside the brackets, square of x will give you x squared. That's why you have to take the 2 out as a common factor, even though it's not all in common. So here, by taking out 2, what should be inside the brackets here? Can I please have Yuna? What goes inside the brackets?
X squared plus 2x minus 1 over 2.
Beautiful. That is correct. You essentially divide every single term by 2 because you're taking a factor of 2 out. So 2x squared divided by 2 gives you x squared. 4x divided by 2 gives you 2x. And 1 divided by 2 is 1 over 2. Okay? Now from this step, you can then factorize by completing the square of just the inside. But you don't ever ignore that 2. Alternatively, you can't ignore the 2 because in this scenario, you're solving. And because you're solving, there's a 0 on this side. That's 2 times something. So I can get rid of this 2 by dividing both sides by 2. So that helps your sort of calculations without writing that 2 all the time. There's a times there, so how do you get rid of that 2? You can just say divide both sides by 2. 2 divided by 2 on this side cancels out. And 0 divided by 2 nicely makes it just 0. And then you're just left with x squared plus 2x minus 1 and 2. Now, why didn't we do that in the previous exercise in 5F? It's because we didn't have equals 0. We had an expression and we were factorizing, simplifying. This one's solving. So I can only do this when I'm solving. I see my year 11s and year 12s, they just add a 0 out of nowhere. Okay, zeros don't just happen out of nowhere. I'm actually solving for an x-intercept. That's why that works. So you just got to be mindful with your thinking. What are you doing and why are you doing it? You can't just cancel out 2's because it makes your life easier. You have to question what you're doing. If you're solving, it's okay. Simplifying, no. Simplifying the expression stays the same. Okay? So here, we're up to this problem now. Same idea again, just like before. We've got x squared plus 2x, and I've got that minus half. It's equal to 0. But what I want is, I want to complete the square. So I need to think what number and what letter goes inside the brackets. Let's go with Toby. What goes inside the brackets?
Would be x plus square root of 2.
Ooh, not square root of 2. Remember, to get that 2x, according to the formula, it is always double this one, and then when you square it, you get the last number. Okay, so what number is doubled to get you 2x? 1. So it should be x plus 1, pointing to the expansion formula, double the 1 times the x will give you the middle, and then squaring the last number will give you the very last number there. So what last number am I missing? What's the last number? What do I need? Plus 1. Very good. So it's plus 1, then minus 1. This will give me a perfect square. So plus 1, that right there, x squared plus 2x plus 1 is the expansion of x plus 1 squared. So just look at the formula again from 5a. That's the relationship. Then you got to work out fraction-wise. Negative 3 over 2. Or think about it, 1 with an extra half makes it 1.5, so 3 over 2. And they're both negative, so hence it's minus 3 over 2. I'll do it in purple, actually. Minus 3 over 2. And it's equal to 0. Again, up to the step. Difference of perfect squares, or you can use inverse operations. I prefer inverse operations. So here I would say that's a minus 3 over 2. Instead of minusing 3 over 2, add 3 on 2 on both sides. Negative 3 on 2 plus 3 on 2 cancels out. You're then left with x plus 1 squared is equal to 3 on 2. Get rid of the square by square rooting, but like I said, every time you square root, what must you be careful of? Plus or minus. Okay, every time you square root, there is a plus or minus answer. These two cancel out. You get a plus or minus root 3 on 2. And then finally, to get x by itself, I need to subtract 1. These cancel out, and x is equal to negative 1 plus or minus root 3 on 2. I'm going to zoom out so you can see. Okay, and again, you don't have a whole number. It's a decimal number, but it tells you what x equals to. All right, team, I'm going to stop the video there. That's 22 minutes of my explanation. That should tie in 5F and then how to solve as well. So it puts it all together in one nice exercise. It is your session to catch up.